Ba, 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 da, da. Hey guys, today today we're gonna do some programming, and we're gonna program. Yeah. Oh, what am I watching? Oh, it's me. Oh, you're not supposed to see me. Anyway, I was thinking like, man, assembly really, bro. We do not need this. Assembly really helps me understand better how stuff works under the hood, bro. I'm like, I'm pretty cool. You start off, you initialize data, you do stuff with data, and then boom, you do stuff. You make a return. I guess 80 int 80 is like return, but I don't know. But NASA, all you gotta do, make an object.o and compile a couple things and do some linkages, and next thing you know, you got yourself a thingamajib. And so today I want to explore writing more assembly stuff, but actually doing the interop portion, because I now have an idea of how we actually make stuff to work using jumps and stuff, and there's a bunch of other stuff. I actually probably want to pull up a reference. Honestly, this will be my reference for today's episode. Subroutines. There's like a section about we don't jump subroutines or what. Bunch of stuff going on here, but this is gonna be for like, I'm gonna cover this more in detail in my videos I'm gonna make, or I'll just do more like assembly stuff with this. Honestly, assembly is not actually that bad. It's kind of interesting. I wonder how you make a compiler or an interpreter, but those are not things I need to be thinking of right now. Let's go ahead and open up our Kate. And I already made a video on Hello World, but this is how you write the return function pretty much. 0A hex. Oh, that's the delimiter, I guess. That's 20. No, it's not 20. It's A is like 10. So 0, 10 hexes. Actually, that is your delimiter. That's like your end of line kind of type of thing. Let's see if I can write my own assembly program without using the book. And without using this. Well, I can reference this. This is okay. We just need to make the sections first. Like, that's what I'm going to do first. Section.data. And then section.text. And then I think we just need to put in our stuff. So in the data section, let's create a initialization for data. And then in this section, let's create our code. Global. I feel like with multi-boot headers, I wonder if I could compile one from dlang. Anyway, we need to extern. Let's extern kmain, since that's what we did yesterday in the C# example. And we should be on our way towards what we need then. Oh, right. I didn't initialize the camera, did I? Oops. Oops. That's kind of bad of me. Let me fix that real quick. Integrated webcam? Oh. Can't tell what angle that is. Okay, hopefully that's the one. That's good. Bro, my screen be trying to sleep on my main system, bro. System B for system, bro. Okay, that should be it. K-main. Wow. Or extern my function, or... But extern K-main allows K-main to be called from this code. So technically, that's what we want. And then we'll just focus on the actual stuff. You need 3 things for grub. Flags, flags the multi-boot number and then checksum. However, the flags are made by Memoline. What's the other one? There was something else. But basically, you just need a couple things. So then we need, we'll start with flags, which is made by the first 2. And these need to be done with DD. Thing 1. Actually, there's a line to a line. Well, a line comes at the end. Checks the magic number. And then continuing on from there. Probably gonna... Might just call those thing 1 and 2 for now, but I'll figure that out in a second, what they actually are called. Basically, you're going to pipe those 2 together. They're going to be done by shifting the first one by 0, and then thing 1, thing 2. Good naming conventions. Bro, this looks like shit, honestly. Flags is thing 1. Pipes thing 2. Zero. And that's all I need to do. So continuing down. Now I just need to figure out what this one is. I think it was an alignment thing. We could have that. But, just in a line. Actually, you don't need that. Let's open what we had yesterday to reference, just to compare how correct I am. Probably not. D-lang BadOS boot.asm. These are equals. That's... Ah, they do the DD in the aligned in this section? Section.text, like the first things they're doing. Though they don't have a start, so how does... That doesn't go to the entry point first. So... Let's redo ours to do it correctly. Global start shouldn't be at the top. You don't need to extern K-main at the top. the way that's gonna all fall under is like the actual section.text. Global, as you can see in the hello world example, is quite literally right under the section.text. So extern and global go under here. Now with these, they are going to be equals because these are going to be undefined constants until we actually go to use them. So that is done correctly. Although in the hello world example, I think we do it with ddb. Now that's because this is not constants. So when we actually go to use it, we just put it into a register. Although using equals and dd are kind of different. I think it might be better to just go with using dd on these, but I don't see why you would need to put... Actually, we probably pull them into existence in boot ASM underneath a line 4 for a reason. I figure dd gets aligned by 4 when we do that there, so... When we call this, it calls global start, which means our start of the program. It's going to be at start colon, and let me just figure out my settings over here, because the screen is just cool. There we go. I figured that out. Enter tab. So we got our starting points for the program. We're gonna do all of that here because when we enter section.text, we're gonna pull all of this stuff. I forgot the checksum. Checksum, checksum should equal... Let's go ahead and make these spaced out too. Flags, or negative of flags plus 0x1. That gives us our checksum, which we saw here yesterday. Flags plus magic. The names don't really matter that much. Although, yes, we could make them all caps. But, what are these first two called? Module line and mem info. Alright, let's go ahead and do that. Rename them to that. How are they piped together? Are they thing 1 and thing 2, or are, what is the pipe on this kind of like? That's my question. And I'm gonna look into that. Let's see. Do 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 do. What are they called again? Oh, in Buddhism. Module line and mem info. Okay, I was right to say that it was the first one and the second one. And mem info. And that should be good to make our actual next portion where I'm going to put these into existence, bar these ones. These ones are not surely going to be used because they just define what flags is. So flags now. We just have to put flags into existence. Check some. So we just have to initialize all of that in the actual main section. Let's see. How do we do it over here? We do our line 4 in section.text, and of course the entry point for the program is going to be at start, so I'm going to go ahead and say that the entry point is start. We need to just go to start. Like example here, goes to start first and does the initialization inside of start. Since we're going to pull the constants into existence and then have them basically dd in this, which is basically whatever dd was. I forgot what it was yesterday, but we figured out what it was yesterday. These also should be like that for the correct syntax, but line 4, and then we call all of those into existence. So flags, dd, and then checksum, dd, and then the last one, which is k, not k-main, magic in the middle. Magic, dd. Let's go ahead and make them look kind of decent. Moving over to here. Oh, they're just done with dd, flags, magic, and checksum in the align 4. I'm pretty dumb. I got it backwards, but that's okay. I can just erase these and then we'll have it like that. Let's go ahead and do that. dd. Yeah, I'll just put dd on all of these. That should be good. Not yet. We will not save it to there. Alright, so that creates that. Now, if we look at the one I wrote yesterday, lines them kind of like that, so they're centralized. Although dd is a pseudo instruction, it's basically not it's not the same as a normal instruction like halt and jump. It potentially is done here because they are pseudo instructions to begin with, and so they can't be done inside of an actual start or like a label. And we're not going to need to go back there either, so potentially these don't go under start, but they go under our extern and our global for that specific reason that they're pseudo instructions. I haven't gotten that far in the website that I've been reading about it, but I'd figure that's probably why it's done like this in the OS Dev guide for the C# one. dd, and then dd. So that's flags, magic, checksum, line 4. You wouldn't want to put these at the top. Why would you global start? Did I copy that from the guide, or no? I just wrote that myself probably, because I'm dumb. But you want to put that underneath your .text or in your .data, one of those two. Then your program will know. But section.text probably is the better bet. And externing allows you to call an external function inside of this, so as long as in a C format. So in our start section, we'll be able to do stuff now. Huh. This is a good question of what do we do. So in the other one, they do halt and then jump to start. And that's how you would do a jump halt. So that's interesting. And then we can save this. I want to save this in a new folder. Alright. Save. Bad, or let's call it boot dot s. Alright, so compiling it is not, or assembling it's not hard. All I have to do now is assemble all of this, and then we'll be able to do stuff. Now, interesting thing though is that we don't actually call kmain from anywhere. We need to call kmain. So I think that happens here, and we put our call for kmain, and then after that we run the jump halt, so that will be the CPU idling pretty much if it doesn't have anything to do. Although we might need to include checks for it. I'm not really sure. We'll just figure that out as we go, honestly. Let's go ahead and put in a call for kmain. I think you can just do call. I'll have to look up what that does though. The call and return instructions also use the stack. When you call a subroutine, the address you called in your program is pushed onto the stack. Let's see. Call our function to calculate the length of a string. Right, that's what they do in the first example. The first example teaches you about a lot of stuff, but call is important. I guess in the middle it should call and see if it has... There's also push and pop, which I'm curious about what they... Oh, they do call in lesson 4. So right, like you can write an assembly program and call it into your assembly program, which makes sense. I mean, that's pretty standard. I think most languages give you something like that, a module almost, in a high-level sense. But we'll call kmain here because I'm not sure if I need to put it in the middle. But we'll figure it out. We'll screw it up and then do it again and keep working until it works. Alright, we've gotten through all of what I believe is the boot portion. And then we just need to set up our high-level code. Let's go ahead and do import standard.standard.tio. Actually, you can't do that. No imports. Maybe import core.os is fine, but nothing else could really do. Maybe import core.runtime if you want to use the runtime. You gotta go to sleep, man. I just got up, man. I don't know why you're telling me to go to sleep. I've got plenty of work to do. Let's see. We'll do extern C and do colon. And then we'll do what else? So that means every function after that colon is going to be externed. So now all I have to do is just write my functions. They'll all be formatted as a C compatible function. So void main, and then we need to do some stuff. We need to import core.volatile. Which gives you access to something. core.volatile. Volatile load and volatile store. To from memory location. These functions are recognized by the compiler and calls to them are guaranteed to not be removed. This is also outdated though, isn't it? Or are these still okay with dealing with memory mapped I/O? Let's see. Memory mapped I/O. Zoom in a bit just because we need to be able to see. Memory mapped I/O, port managed. There are two complementary methods of performing input-output between central and peripheral devices. Okay. Implementing access via chipset, an alternate approach is using dedicated I/O sensors, commonly used. Memory mapped I/O uses the same address space. It serves as memory and I/O. And the registers of the I/O devices are mapped to associated with address values. So binded, basically. In other words, so like, let me draw it out. I think I understand what it's kind of saying. All right, let's create my example. So I have A, and I have device B. Let's say B is the peripheral. So it's not like a connection like a wire, but this has memory on it. And then this one has memory on it. And then the memory is, well, there's no memory on this. No, that's not how that works. But there's memory on this. So when this device is plugged in, it gets an address on here. Something like that. Some address. And that's how that works, basically. Basically binding this device to a specific address in there. Which means there's definitely one for VGA, and one for audio, and one for such and such. An example of the latter is found in the Commodore 64, which uses a form of memory mapping to cause RAM or I/O hardware to appear in the 0xD00 or 0xDFF range. Memory mapping also means that it's probably defined in grub how the memory map happens, or in the BIOS documentation. Port mapped I/O often uses a special class of CPU instructions designed specifically for performing I/O, such as the in and out instructions. Found on microprocessors based on the x86 architecture. These are different forms. Can copy 1, 2, or 4 bytes, out B, out W, and out D respectively, between the EAX register or one of that register's subdivisions on the CPU. Interesting. That's actually something I didn't know, but I'm sure I'm going to learn that eventually, learning assembly code on the side. We might be able to just write my own functions for that, using inline 86. This is very simple to read, so I think this will help me a lot. So 80 to 88F is general purpose. 0 to 7FF. Oh, a simple system built around the 8-bit microprocessor might provide the 16-bit addresses, allowing its kibibytes. Whoa. Kibibytes. Kibibytes? programmed input output. Like GPIO pins would be programmed input output. So memory mapped I/O is interesting. Also, a lot of what we're going to be doing is just written inside of the lowest level language, probably in line 86. We import core.volatile. We'll be able to use volatile load and volatile store and stuff to get I/O from the devices then. Although you need a pointer and such. Let's look at the source code and see how it works. I reckon the source code is also written in D, or a little bit of assembly in there. Okay, volatile store is interesting. They also use in the documentation tools where you do a big line like this, and this creates your documentation. So basically the way this works is it's a D-lang format for documentation. No throw, safe, and GC. Which means, first of all, we can call these functions that don't have a GC and are safe and no throw inside of an environment where there is no GC. So you can extern C these pretty much. Whoa. Anything else probably risky, but this one I know for a fact you can extern to. Assert R equals M. But this doesn't really tell me what volatile is. Where is that coming from? Like what are these then? For each T of TT, U byte short or uint. But then you do, bro, I cannot read that. Then you put T of U and you put T pointer and P equals and U. Oh, it's a type pointer. Oh, right, this is interesting. Volatile store. And that puts P, which is a pointer to, and U, or which is also a pointer to something. I don't remember what exactly the difference between the ampersand pointers, function pointer maybe. I believe that's what it is. It's a function pointer, yeah. I think that's what it is. Yeah, function pointer. Probably. I could be wrong. But volatile store P, which is here, and that's a function pointer to U, wherever the U function is. There's no imports, but this is still up to date, I would say. Probably up to date. But I don't know what it's really pointing to. I guess, actually, no, it's pointing to the variable U, which is of type T. Alias TT, T dot 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 equals T. It's a unit test. This is done to check stuff, I guess. Or this is some kind of at system unit test. Maybe it defines these as potentials that it could be, and then this is like to say what the type is, something like that. Could potentially, possibly, sort of be. But how do you get access to MMIO? For my system, right? Let's read from Oracle. Wow, Java. Java, my favorite language. Java the Hutt. Whoa. Java is such a retro language. It's a retro language. Like, I'd say Java's retro. If you program Java for anything, you're just a retro programmer. That's cool, but Java sucks. Big Java sucks. Bum bum bum. I hate Java. Wow. Memory mapped IO, MMIO, dev community. Wow. There's an address, the VA to PA conversion. The CPU always issues virtual addresses before transactions reach the interconnect and memory management unit. Translates VAs into physical addresses or before the interconnects the memory management. Okay. Something the MMU uses translation look aside buffer for cache translations and performs a page table walk on TLB misses. SOC physical address map. My brain's blown. Hold on 1 second. So MMIO, when it happens, it can find what devices are present on a system. Which, I mean, that makes sense, right? But think of it this way. SOC, I have quite a few boards that have SOCs. I'm just saying, if I can map an SOC, I could be building myself. Build apps with Google AI Studio. How about you suck on my censored, redacted, scrolling down. Bro, why? Twice the build Google with AI Studio. Get slapticated. Slaptified. Anyway, I kind of have an idea of what we're doing. But I don't really know what the core what we're putting into. So we just need to find that out. So how do we do memory mapping ourselves? So these are for DVR memory. That's for the UART stuff. Occupying fixed physical addresses defined by the SoC. Linux receives the physical MMIO layout from the device tree. DT reserves the corresponding regions and builds virtual mappings with device memory attributes. A CPU MMIO access follows the same initial path as a normal load or store. Okay, back. We might just import this down here, and then we need to call this as kmain. I might write it in ASM if it's not possible. Let's create a tool that gets us a memory map. Let's see if there's an example of it. Map. The FizzBuzz programming challenge recreated in NASM. How to make a socket accept incoming connections. Whoa, that's actually pretty cool. We're going to learn how to connect to a web server and send an HTTP request for a web page. In assembly? Bro, like, you can go all the way to level 36. Bro, if I'm a level 36 assembly user, bro, I'm a fucking master. Volatile. Volatile store. There really is only 2 of these, right? Volatile store and volatile load. It needs a U-byte or something. One of these 3. Volatile store, and then you just need a pointer. I guess that pointer can just be whatever. I have no clue what valid pointers are. I guess the pointer's the address, actually. The pointer's the address for sure. So let's do 0x00f or something. I don't know. 0x0f. How do you find out the fucking memory mapped addresses, though? Find MMIO address. Of PCI Express cards. Yeah, this is not gonna help me. I'm not that level yet. You can actually change the values of BARs and address changes for that device. Of course, you have to be careful that there aren't any. BIOS UEFI sets those to whatever it wants before handing control over to your bootloader. To make sure that your OS doesn't conflict with them, it gives you a memory map indicating these regions. Bro, Red Hat. Red Hat is telling me the answers right now. I assume this means the OS can't simply reassign them. What are the implications? There aren't any limitations as far as I know. You can set them to any physical address. Of course, you'll want to make sure that they don't collide with anything. Devices behind a bridge need to be assigned different addresses within the bridge's address. What does a bridge exactly mean in this context? Doesn't know anything about the device behind it. So if you don't want to do this correctly, or if you don't do this correctly, you won't be able to access those devices. On the other hand, you can't just have overlaps. Okay, you can't have overlaps at all. Okay. In AMD CPUs, any CPU module can catch a memory access and implements MMIO. So I guess maybe I should read the Intel docs. Cinnamon is on Wayland now? Oh yeah, I heard about that. I've heard about that for like a week now. I don't like Wayland. I'm gonna be honest, Wayland is kind of lame. It's kind of like, but the X11 is still there? Yeah, but they're gonna eventually not have that. Oh, maybe I should do LSPCI? But how does LSPCI work? We're just gonna copy Linus Torvalds. Wow. Wikipedia before we go to the manual page. Example output. LSUSB to find USB devices. LSPCI source code. LSPCI source code. Let's see. System Z boot, bro. Maybe. Maybe the devices are... I mean, X11 is cool, but Xorg is dead, and X Libre is getting banned everywhere. Why is X Libre getting banned everywhere? What's wrong with that? Like, why do people like Wayland so much? Maybe it's like the new cool or something? Like, I don't know. Like, X is amazing. Phoenix isn't out yet? Oh. Let's go back. What exactly does all of this mean? Bro. He's got like the transparent terminal. Let me do LSPCI to demonstrate. You got LSPCI. And that pulls every device on your system. Beep, beep, beep. Amazing. This also gives you addresses to every device, including and limited to VGA. But how do you find the VGA device? Like what? What is VGA device? Got into political. Man, this world is so lame nowadays. Like, bro? Just develop software. Stop getting crossed into fucking other realities and stuff. I don't understand. People are like, yeah, politic, but really just develop good software and stop getting mixed up. That's what I think. I think people need to realize that if you're gonna develop code, just develop code and don't get lost in the sauce. Unless you want to develop like Temple OS. I want to make my own Temple OS. I like that guy's videos. He's pretty cool. What a legend. ISP understand LSPCI. LSPCI. Your browser must have JavaScript in order to display this information. Oh, my data is being stored now. LSPCI. Oh? So maybe you can grab the device information from that? Bro, how does LSPCI find MMIO address? We'll see what fucking brave AI says to me. I've been trying to ignore it, but I'm gonna have to look at it today. Linux command line, operating system drivers, or direct hardware access. Enumerate PCI devices. Bro, this is not even good information for me to be using. I have no idea how that works. So, I guess I'll have to look at this again. Bro, the ad slop in this one is terrible. It's eating me too. Alright, here's what happens. CPU store. That's too much for me to read, bro. MMIO regions, VA to PA conversion. Maybe system's physical address map. Also, OBS is quite buggy in the long run. It's quiet, buggy in the long run. I don't know. OBS is what I've always used. Unless there's a new cool thing out there that's actually pretty good. Linker scripts explain controlling memory layout on bare. Oh god. I've lost connection. Did I drop connection? Oh god. I'm so sorry, guys. I think I dropped connection for a second to my network. What is this? Intel.com content documentations 10th gen core families datasheet. Is this the Intel docs, the Intel Bible? 10th generation Intel processor families. Let's go ahead and, bro, read the docs, bro. Read the docs all day long, bro. I mean, honestly, if you want to be good at anything, you gotta read documentation to do it. PCI devices and functions. You should use Boomer by Soding. Let's see. Cards. Oh. You dropped. Cards. Oh. You dropped the connection. Oh shit. Bro, do I just have to hold it right there for now? I have to hold this or it loses connection. What? Oh my god. Push it in there a little bit farther and then... Just gotta do that the whole time. It won't lose connection. Bro, Chud react this guy though, bro. Chud react him. Nim and Nix and GLSL. Pseudo Pac-Man SYU. Oh, I forgot to do my pseudo Pac-Man SYU today. We just need to get a memory map, honestly, or like an address map. But where would you would start from like the bottom of your addresses and then work your way up? I'm gonna bookmark this. I'm probably not sure if I'm gonna install it right now, or I'm definitely not installing it right now. Maybe this weekend we'll look at doing that and then see if it works for me on Sunday and then go from there. The processor contains multiple PCI devices and 674-page book, bro. Honestly, I like paper copies because I can read those better. I can't fucking read digital stuff very well. I lose focus so easy. But I'm gonna continue on. System address map. The processor supports 512 gigabytes of addressable memory space. Wait a second. That's the 10th generation Intel processor? Wait, oh. For RAM? Like, that's your RAM? It's 512 gigabytes, bro? You can have 512 gigabytes of RAM. God damn. That's modern technology right there. I was like, hard drive? Nah. Build from source because the AUR is still a landmine. Bro, the AUR was a landmine before it even started, bro. I'm just gonna be honest with you. There's no reason to use the AUR. It's been a landmine the whole time. GGC, graphics mode select. I mean, I guess there might be a reason to use the thing, but... This is really cool for people. This is really good documentation. Oh, what's this? System address range example. So I guess part of what makes computers kind of interesting and usable is like this memory mapping stuff and stuff like that. Is you still have to store it into like memory and stuff. The BIOS does a lot of that. The BIOS handles the addressing for different things and creates like addresses for the devices and things. Video area. That's for older devices. So 0A, 00A, 00H, and that's hex. So if you put it in assembly, you'd put this into hex. So if I were to use 00B FFF, that might be in my video range. Let's see, legacy video area, both legacy video address 0A000 and 0B000 can be mapped to processor graphics to the PCI Express or DMI interface. The legacy video area is not available for SMM use. I'm not sure what that means, but the legacy 128 kilobyte VGA memory address frame buffer 00A to 00 to 00B FFF. So it goes up. It has 1 in this section, but a huge amount here. So you do have quite a bit of headroom there for that. So that's the memory space for VGA, I think. So we're going to use that. 00A. And then underscore 000. And if this is wrong, I think with the Pentium processor, potentially is different. Let me go up to a different documentation because I'm pretty sure the Intel docs cover this. Control F, i386. You're there's no i386 VGA. No VGA info. Video. Take me to that, please. (2011) Pentium, bro. Xeon. Xeon is so cool. Atom. I have an Intel Atom processor, but it's like, bro, Intel Atom is cool, but is it really? Smart memory address and some other stuff and more stuff and Pentium, bro. Pentium processor, Extreme TM edition. NetBurst, SIMD. Let's scroll into it. Right, there might be a lot of stuff on the memory mapping in here. I just don't know if it's 00F or 00. What's the i386 though? What's the i386 VGA addressing? So I think, right, we can use up to the one thing. I'm pretty sure I can go from 0A to 0B. Bro, look at that fucking rusty ass computer board. This is like ancient technology. Die of Intel. Oh, that's cool, bro. What the hell? Like, what is that? CPU die image? Wait, these were like still to where you could tell what's inside there? It's like not even atomic. Like, this is still... Damn, bro. That was in that period of time. Like, you can see the individual, like, transistors, resistors, and shit. Like, you can see the entirety. Bro, this is crazy to me. Like, I want to just want to nerd at this thing for, like... Bro, like, look at this shit. You can't really tell what everything is, probably because of the camera quality, but... Unless this is the back of it. And not what I think it is, but, I mean, this is still really interesting to look at. Like, just look at how that's, like... This weird triangles. Multiplexer technology. Triangles, bro. There's just random triangles in there. It's like abstract art, honestly, but... I really don't like this. It makes me feel weird, because, like, I look at it and I go... I just get this weird feeling, like, it just feels so abnormal. I'm like, bro... I'm obsessed with that image now. It's just weird. Weird to me for some reason. Anyway. We now have this. And we need to give it... So that's the pointer. And then we need to give it a another thing. Which I don't really know exactly what the other thing would be yet. I mean, I looked at it like 10 times. I should have remembered what it is. Oh, and then it needs a U byte for the value. So... For example, if I had this string like hello world, for example, we would need to do a for each loop probably. It can take up to a U long. So we'll do a for each loop. For each chr semicolon hello world. And that allows us to do that one loop, but like really easily. I don't have to write assembly for everything, because assembly... No, assembly terrible. Although I'm not sure I can use a for each loop. I hope I can. I hope I can use a for each loop. I mean, for each loops are just part of the language at like the lowest level. I'm pretty sure I'll be fine to do that. So we need to do volatile store and then chr. And then that's pretty much it. So that's where I'm going to close the brackets for that. I think this is how you put letters on the screen. There's also a way to add colors, but you also need to clear the screen. You would need to set a height and a width. But we'll try this out. Also, if you have something already in an address, it changes the color of it when you write over it. So if you screw that up, then it will just re-overwrite it, and then it will kind of edit the value that's there, but then do weird shit. So anyway. We'll save this one as kmain.d. Although there's a mistake here that I didn't address when I was writing it the first portion. Couple mistakes there, but that should be good. CD into new folder, not hello world. Maybe it's in D-lang actually. CD into D lang bad OS2. Alright, let's go ahead and begin with the first one. What we do know is that we need to do DMD or LDC2 or GDC. One of those will get us to where we need to be. But let's do DMD-ELF or DMD-H. Or maybe we should do the man for this, because this will probably be a lot easier. Maybe I'll just pull up the manual for DMD compiler. I want to do it with DMD since it will be easier for me. There should be cross-compile targets. What? DMD compiler, please. Digital Mars D compiler. There's document pages here on the Arch wiki. Options file.d. We need to compile to an object. Compile only, do not link. Oh, it might automatically link it. Generate documentation with a capital D. Generate position independent code. Add symbolic debug info. We need to look for format because that should get us M32. Let's go ahead and do that. And then we should just be able to do an O. Is there like an O? Optimize. Do not write object file. And the object file is important for actually linking or combining it with the other thing. Also, usually when you write these, they have a linker script. Which means I have to relearn how to do all that shit, but... God. Oh. Me, I am tired. Let's go ahead and do DMD-M32. Which gives you a 32-bit executable. kmain.d, and then do -o kmain.o. OF. So go with OF. OF or OD. To open browser on manual. Open the browser for the... God damn it, you just don't have a manual page inside the actual thing. Scroll up through these. Oh, you might want better C as well. We might just do it with LDC. But I kind of want to try it out with this. M64 gets you a 32-bit executable. Unit test, vverbose. Do not write object file. OF equals... Ah! I'm dumb. Volatile store are not callable using argument types. Alright, and we'll just call this a cast. Cast 1 byte, 2 byte, 3 byte, 4 byte, 32 bits. Cast uint. That should be a 32-bit number. Excuse me, what? Not callable using types. Uint immutable car. Ah, cast 2 U bytes. For each car, just cast a U byte. That should be it. Candidates are pointer. Ah, right, I need to cast the first one to a pointer for the uint. And that points to our memory address. Can only point a pointer, not an int. Maybe this just has to have that at the end. Just call that the pointer. No. Oh, no. Cast to a U-byte pointer. Oh, wait a second. What am I doing? Cast uint pointer. That's how you do this. So that should give us what we're looking for. It's trying to link it. We don't want it to link. Where does it say does not link? We absolutely do not want this thing to link on its own, because that's my job. My job is to put it together. dash C. M32 and dash C. So what's going on in this error is that the linker is not able to do a 32-bit link, probably. So it's not linking, and that's fine. That's what we want. We don't want it to link. If it links, that's bad, because that's what I'm supposed to do. Input file. How is the input file the output file? ls kmain.d, right? So kmain.d. I guess I have to add a dash if as well. Bruh. Why you have no dash if? Ah, there we go. Yeah, that makes sense. So the entire linkage is gone. So now if I ls, I should have an of, or kmain.o. So now I can call kmain from my actual assembly code. So if I can compile that now, nasm-f elf32. Bro, what the fucking shit, bro? God damn it, that took way too long. nasm-f elf32, right? That's gonna be that. Although we also, I could just pull up the shit I did yesterday. LD, and then we also need nasm-f elf32 hello world.s. nasm-f elf32, and then our program, which is boot.s. ls. We now have boot.o. So now I just need to LD. This is the part that can potentially delete a file if you screw it up. So let's go back through my stuff and see what I can, because I saw the LD stuff yesterday. LD dash, and you do your dash O after you do the dot O. So dash O after I put my dot O. So LD dash M dash H, because I need to put in the dash help, I guess. There should be one that says dash M or dash dash. One of those. I think it's either dash M or dash F. I actually have it written down somewhere too, because I was like, when I did this the first time, I was like, yeah, how do I do that? Bro, this is a lot of stuff. LD. Bro, I ain't doing that today. Let's just use the command from above. It's not gonna help build memory though. I like building my memory of it so I can be good at it. M. So it's a dash M. Let's go ahead and put our boot.o here. Boot.o, and then the other one should be hello world, or not hello world, but boot.o, and that's to make regular assembly into the thing, and then kmain.o. Ah, that makes sense. I might have fucked it up though, because I might have Oh? Okay, that makes sense. Maybe it didn't do it? Okay, so it takes boot.o and kmain.o. First two. Okay, that's interesting. Go over to here. We still have boot.s. Okay, that's good. Let me nasm that thing. nasm-f elf32 boot.s. Then we run my ld to make my boot.o and kmain.o into -o boot. And then it says undefined reference to kmain. And it says ld kmain. I'm just trying to see if I can see. What I'm trying to see is if I can skip making an ld script and just avoid that entirely. In function _start, undefined reference to kmain. What's my function called? Void main? Oh, right. Kmain. Redo the whole entire thing from the beginning. Alright, so we're gonna go ahead and do my dmt-c-m 32 to create my output file of kmain.o. Then I'm gonna do my nasm to get my boot.s correct, even though I probably don't need to do that. And then I need to do my ld, undefined reference to DSO registry, which means that my compiler must have put the D something registry. This is important because it means there's still high-level code inside the program. I just don't exactly know what that is or how that exists, or if that's like something to do with all of this stuff. But I mean, that's what we're here to find out. We've imported core.volatile. We ran our extern C, so the code should be externs. Maybe it's the cast or the pointers or something. Let me look at what _DSO registry would be on the interwebs. _D_DSO _registry _. I switched to Alpine because I'm tired of compiling. That's fair. I've heard Alpine's pretty cool. Used for DLL support. So probably something to do with compile time. I would assume it's probably something to do with compile time. Probably run -better C. Wait, what's this? This week in D, October 9th, 2016. What are we cooking up? I was working on trying to make my own OS. I'm pretty close, I think. I just need to get it to compile correctly. I might need to add constructors and destructors, but mainly what I need to figure out is what the undefined reference to that could be. I think it's just to do with the fact that we use DMD compiler and not one that's actually reliable for this, like GDC, for example, which would be recommended to use GDC, not DMD compiler. But I mean, I don't think anybody used or would use DMD compiler for this, honestly. I have a huge delay. Yeah, I don't know what that is. They were doing maintenance on the network. The ISP was. So I have no idea. They could have changed something. Ugh. It could also just be that my pie is frying. or they're just tired of me streaming for 7 hours on their network or something. I don't know. Default lib gives undefined reference to DSO as an internal D runtime function that gets called with information about the executable or shared object. It's part of D's DLL support, generally useful, but I don't think it should be required for a C Hello World program. D is terrible. D is a bloated language. D without structs is almost useless. Struct is a must-have. Even C has that. So let's add one. Maybe do dash better C. I guess that's what I could do. Is add a dash better C to my DMD command. Dash C. Let's add dash better C in there. Probably put that first, dash better C. Let's see. TBH computers bloat? Yeah. The whole thing from the bottom up needs to be redesigned. The whole thing from the fucking atom needs to be redesigned. It's all bloat. Oh, wow. Bro, I'm kinda... Oh, I'm tired, bro. Just got a little bit more to program. Underscore G shared void. So like a global shared for that, but oh, better C is a capital C. Better C as capital C is fucking cringe, bro. Why not make it lowercase like everything else in the language? Alright, we'll now run our NASM. And then we'll run our LD. It just works. No errors? No errors doesn't mean it didn't go wrong somewhere. AKA programmer error. LS. I now have boot, so let's do Kimu. Is it caps? Did I accidentally turn on caps lock? Kimu dash something. Kimu dash or system dash I386. That pulls up a Kimu instance, as you can see. And also tells you a bunch of stuff. Very neat. Neato. Now, if I run Kimu-system I386, and then I do dash help dash H, I should be able to get information on what I can actually put in there. And I should be able to put in a specification for dash kernel equals, or something along those lines. I just don't remember. These are for net devices, so you can technically boot from a net device. Like imagine you have a NAS and you want to boot from that maybe. That's pretty crazy, honestly. Or maybe something like that. A USB device, displays, you'd specify displays, drives. See, this is where it's at, man. It's in the Kimu, bruh. At mem file path. Provide backing storage for guest RAM. Dash H dash machine type. There's also a lot of sub commands apparently. This is a lot of good features, but the main one I'm looking for is probably expert options. Compat, nah. I mean, maybe compat would be required, but for something else probably. Honestly, I'd read the manual page to learn more about this, but it should also give you a list of options, disk image. I mean, I think I could probably just run Kimu boot. Wow. Oh. It did something? No bootable media. Image format was not specified for boot. Probing guest raw automatically is dangerous for raw images. Write operations on block 0 will be restricted. Let's go read the Kimu doc since I don't know what I'm doing, bruh. I also should take notes on the fact that we need to compile stuff with those, with specific commands. So I'm gonna make some notes for myself. For this one, dmd-better c, which can be lowercase, better c dash c, because that prevents any potential bullshit where the linker runs and then does weird shit. And then you need to do another one, which is to create dash M32, which sets it to a 32-bit format for the 32-bit i386. And then you need to do your output file comes after your kmain.d, and then you can create dash of equals kmain.o to actually integrate that with your assembly. Then you run your nasm stuff, and then you do nasm, which I'll write out the format for that. So nasm's actually pretty easy. Nasm was like dash f elf32, and then you do your s. And bro, sometimes this gets confusing because I'm like, well, this tool does it that way, and that tool does it that way. Like, it's kind of just confusing, bruh. nasm dash f elf32 boot.s, which will automatically create a .o file. Boot.s, and then you need to do ld dash m elf underscore i386, which creates that i386 one. Boot.o kmain. Okay, so then we'll just put object files and then dash o output file. That way I can remember what that even means. There's my notes for how that works, and I'll rewrite those down on paper later, so that way I have a hard copy to keep. So that's good. So I'm guessing it tried to boot the image as though it was an image. And that's not going to work, clearly, because it needs to be a let's see, Kimu run ASM. Let's see if what's that. Let's see what that gets me. Because at this point it should just be like an ASM or linked ASM. ASM, bro. Bing, 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 bing. Bro, my brain is frying. Let's go ahead and see what he ran. Why am I looking at that? Why am I not looking at Kimu docs. Or maybe I should just go to OS Dev Wiki, because they probably I could literally just copy the answer from one of those. OS Dev Wiki. They have the information on how to the x86 or QEMU stuff. Let's go to the C# bare bones and see what the exact command they use. CD-ROM. That's interesting. I guess they compile it to that. What does the D1 use? Kernel and kernel.bin. Maybe I should have specified -kernel and then done that. Okay, we'll try that out. And this is how I will figure out the entire workflow for what I'm doing. Oh yeah. -kernel. I don't think you need to be a .bin, but without pvh elf notes. Error uncompressed kernel without pvh elf note. That's interesting. What is a pvh elf note? That's probably something to do with the ELF32, right? Which is the architecture. Some fancy computer science word I gotta learn, bro. ELF. What does it mean? Me, I don't know. But I know it's something I've heard a lot. And also a note is important. It probably tells it what it is. I'm guessing we probably should have done it. Let's try compiling it to a bin like that one showed us. Do that. And I can do my NASM, which should do that as well. Why is there 2 boot.s's? Bro, why is there more than one? Alright, then I can do my linker stuff. Maybe I need to put that in a linker script, but if we do anything with the linker script, I'll just do that next. I'll just look at linker script examples and then be like, alright, well, what do I have, what do I need, and then I'll just figure it out from there. I think you need a BSS section and a bunch of other sections. It should be pretty much just like the same. Once you have one linker script, I don't think you need anything else, really. Unless you want to add some, like, really complex, super awesome, amazing quantum mechanics features or something like that, I don't know. Boot.bin. Then I can run the QEMU system boot.bin. Error loading uncompressed kernel without pvh elf note. Which probably means something's wrong in this. pvh elf. Let's look into what that means. Oh, right, it needs a machine. QEMU system. Try adding this to the command line. But that's for a PowerPC though. Or no, that's for... Ugh. Are you using a cross compiler? The system compiler creates a PE output. Let's see. Uncompressed kernel without the i686 toolchain thing. I don't know if that's okay, but it seems to run fine. So it's either make it ELF or make it have a multi-boot header. I have a multi-boot header defined. It should be there. Maybe it doesn't hit the multi-boot header when it tries to boot it because it's like not in the right place, or the linker script doesn't point it to the multi-boot header correctly. One of those two things is occurring. Let's see exactly what's going on. Yeah, because like it probably could be something like this. Needs all of these. Right. Uh, linker script. But let me read how that even works so I can make my own. But these are alignments, and then that's really a simple linker script. Like honestly, if I wanted to just copy this, it has pretty much every section I need, except for constructors and destructors. But you don't need those unless you're doing something weird like the D tutorial was doing. So we'll just literally copy and paste the LD, and I kind of know what it does. I'm going to try to break it down again and go through it line by line. So we have our entry point at start. We then have a defaulting starting point if it fails to find that, a default section, which is going to be like the whatever this is. That usually just start. I mean, I guess a default section. It's basically a section by section. So you have a dot text, and it has a block, and it says align 4K. Kaboom, lines at 4K, and then you have a couple of these things. These aren't pointers, but they're subsections. So you have a dot multi-boot, then you have a dot text. I don't have a dot multi-boot, but I do have a dot text. I also have a dot common. So let's see exactly what do I have and what do I need to make exactly. So we need dot data, dot text, and they have row data, regular or just data, and BSS. Row data is important as well because it's read-only data, and then data is stuff that can change, which can include the multi-boot header, but this can also include addresses, and so you could like probably you probably define, where is that in the my k-main? You could probably define this address in there. You could define your addresses for, like, this is a constant number. This is where the VGA starts at. So if you already have where the VGA starts at, then your video can just start at this number, and then obviously do your algorithms and stuff from there to get the screen to clear and shit like that. Kind of important. The BSS has to do with the stack, and this is block 4K and align 4K. Let's go read docs on this stuff too, because I don't just want to copy and paste this in there and be like, man, I don't have a dot BSS, which is my stack, and I don't have my. But usually it goes by sections, and it's like you have a dot section. If the section isn't named, it's just 1M. Like, what does that mean exactly? I don't know what that means. So I should go read LD script, which is what we need to do. GNU. This is the bin utils docs, by the way. Oh, wow. Internets. Intranet speed. Basic linker script concept. I think I got the basics down, but I'm sure there's more to it than what I think is the basics, bro. Because I think it's pretty easy, but there's probably more to it than that. Basically your strip concept. Let's go over this. This is important stuff. We need to define some basic concepts and vocabulary in order to describe the linker script language. The linker combines input files into a single output file. The output file and each input file are in a special data format known as an object file format. or we could say OFF, but of course that like or just .o. Basically, this is your .o. Each file is called an object file or a .o. We're just gonna call it .o, since .o is the way to call it. Or you could call it this, but then you sound lame, bro. Call it .o, bro. The output file is often called an executable, but for our purposes, we'll also call it an object file. Each object file has, among other things, a list of sections. We sometimes refer to a section in an input file as an input section. Similarly, a section in the input file is an output section. Each section in an object file has a name and size. Oh wait, so you're defining the name and the size of it. I'm forking assembly, make it look like C. Bro, you're just gonna, at that point you're just gonna make C, man. Somehow, bro, you're gonna have to make silicon that you can write in C then. But that'd be lame. Nobody wants that. Assembly is supposed to be hard. It's to keep idiots like me from playing around too deep. Anyway, I'm so sorry. I must apologize at this time for me being dumb, but I have to keep reading to get smart. But for our purposes, we will also call it an object file. Each object file has, among other things, a list of sections. We sometimes refer to a section in an input file as an input section. Similarly, a section in the output file is an output section. Wait, so I'm guessing D files might by default have a constructors and destructors section because it's D-lang and it's got object-oriented stuff. I'm assuming, I'm making assumptions here, but D-lang, CTRS, DCTRS, which is constructors and destructors. Wow. D-lang. But if you have a linker.ctrs, linker script. This is another website on linker scripts in case you needed another documentation. What do linkers do? Which is C++, and we hate that here because C++ is cringe to me because it's fucking terrible. Literally the world's worst language is C++. I'm just saying that now. If you like C++, be offended, please. We all know C++ is the subpar language to C or D. Even D is better. And D has all the same features of C++. Every loadable or allocatable output has two addresses. First, the VMA, virtual memory address. And the second is the element, or LMA. I'm laughing my ass off. LMAO. Lamau address, bro. Lamau address, bro. I need that. This is the address at which the sections will be loaded. In most cases, the two addresses will be the same. An example of when they might be different is when the data section is loaded into ROM and then copied into RAM. And when the program starts up, the technique is often used to initialize global variables in a ROM-based system. In this case, the ROM address would be the LMA and the RAM address would be the VMA. You can see the sections in an object file by using objdump program -h option. I'm glad I read that, because now I have another tool called objdump -h. Aha! Okay, we're gonna do objdump and then objdump -h option. See the symbols using objdump. There was another one which was like nm, and it does the same thing almost. But sections are important, and then symbols. Sections and symbols, but like everything compiles down to assembly, and it breaks down into sections. And when you want to interrupt programs, you're going to use LD in some capacity, right? So LD is really this important tool that our Lord and Savior Linus Torvalds has brought into our existence, bro. Thank you, Linus Torvalds. We worship him as God. No, I'm joking. I don't know. Object dump. But I think NM was also one of them that does a similar thing. I'll have to consult my notes later, but these are useful things I will use. These are my useful notes. Option. No such file. Then let's go ahead and do an ls again. Actually, what was the one called? It was called kmain. Oh. Okay, so look at this. I got a dot text, a dot data, a dot BSS, dot row data, a dot comment, a dot note, a dot note GNU stack, dot note dot RO, dot row data, strl, dot group dot text, and dot kmain. That is a lot of stuff. Now to see symbols, it said to do -t. So -t gives you symbols, and you'll see kmains at the top. Then you got your text, data, BSS, text. So you need a BSS no matter what. That's for sure, because that's gonna be really important to your OS. I'm guessing these are like some kind of read-write information or something like that. I don't know. This one's just W for some reason. W and F, which is like the one that stands out because it's like shifted one space. Like, what? Same with the F on that and the O here. Pretty much everything else is L and D, except for the top one, DR. A global offset table. Like, look at all this high-level stuff. And then if we do the same thing to like my -t, the other one, like assembly, you can get a really clean operating system if you just write raw assembly like a weirdo. No wonder Temple OS is so crazy, because Temple OS, the guy who wrote it 90% in assembly until he was able to probably write his own compiler, so then he could just compile Holy C, bro. That's probably what he did. I'm gonna be honest. -t, and we're gonna do. Let's do the -h again. Boot. .o. And if we did boot.bin, it'll probably give us some of the same sections. Although if the LD doesn't define what is linking. However, if it defaults the linkage to whatever the D linkage would be. Also, there's another thing, because we're not specifying the actual. So here in this object file, you have all of these sections. It will probably default some of those. And we're going to need to figure that out. But let's go ahead and do the dash t now, just to get some practice on obj dump dash h and t for different purposes. This gives me a symbol table, and I got my amazing stuff going on there. Oh wow. I just realized you all can't see this. Let me go ahead and move this to the other corner of the screen, which also protects my time zone in future streams. But we have dash h, and then we have / obj object dump dash t, which these are useful for finding information about file.o, and then our final file, which is the .bin file. Have we done that one yet? We're going to do that one next, I think. Cool. So those are useful. Let's see. obj dump on just my boot file. .bin. That gives you also symbols. Let's see. A checksum symbol, a magic symbol. So those are symbols. Oh. I wonder if I can write the whole thing in D. I think I can write the whole thing in D-Lang. I just needed this tool to figure that out, because really all you need is symbols and a linker script. And it compiles down into... I mean, the only thing that I'd really check is, like, when you write it in, like, a high-level language, right, you get all of this stuff, like, right up here. But you have more control if your boot is in assembly. But, like, look at this. Like, my magic and flags and stuff are, like, right at the top. Symbol table was boot.s, though. Why is there boot.s in there? Why is... Oh, and then kmain.d is down here. Look at this. So it goes through this whole section. It's like, alright, here's module info. Here's mem info. Here's flags. Checksum, or magic and checksum, goes down. You don't even see what they are. This one's 1BAD B002. This one's E45, which is just going to be like an antonym to this one. Oh, and when we set those, basically we just set module line to 1. We then set meminfo to 2. And then we pipe them together for flags, and we get 3. So that means any changes that are dynamic will be piped into the final result for flags, which then is used to create this last checksum. Basically, checksum takes magic plus flags and... Or no. Yeah, I think it does that. I think that's what I did originally. Magic plus flags... And it inverts that, and that's the, technically, you should just do magic for that. But that's all it needed, other than the boot table needs to be, or the... It calls it has global start and extern kmain, which means that after we get done with checksum, then all of that's here. Unless we were to call extern a lower, I think we should extern after we do this. Because I think that overwrites the definition when we get to the align portion. So I think that's the actual correct formatting for it now. And then let's go back. Let's run -h on it. See what sections exist. I want to see if it contains the regular D sections. And here's interesting stuff. There's a .text, a .row data, a dot got, and a dot plt with a dot comment at the end. The alignments are all not what I think is correct, because the alignments don't need to be that. They need to be the other thing. We need to define them. Here we have the file format correct. K-main is correct. File formatting, and then this one's also correct. But the problem is we don't have a linker script that defines BSS. So we do have a BSS section. We do have row data, and of course we do have like comments and stuff like that. So those do exist. There is no .ctrs or .ctrs. However, if I go ahead and look at a normal compiled program, like let's just write a simple hello world program and like compare that. So we'll make a file new, we'll write hello world. So we'll do void, oh shit. Void main, and then we'll run this, and we'll do write or import stand, me typing weird. Why am I doing it? What am I doing, bro? Is my brain shut off? Am I standard dio colon write ln. This is just to give an example of how a default one looks. Just so I can understand what exactly goes on if you have the full D runtime. Let's throw in a variable as well and initialize some stuff. Let's initialize a magic variable. Let's call it uint magic. And then let's go like that. I think you could probably write the whole thing in a high-level language. You just need to have it formatted correctly on the output. And getting that is going to require some crazy stuff. 0x1 BAD B0 2. Let's see if this hello. Actually, let's create a new folder. Let's rename it to let's call it example. Just make it simple. Example/example. All right, now example.d. Boom. So here we go. I have a magic number again. Let's go ahead and try this, but on it's DMD the example. DMD example slash dot D. Cannot open output file. Example is directory. What? cd example. DMD example. Let's just go ahead and do. All right, now let's run those commands on it. Let's go ahead and run object dump -t. Should be yeah, let's just get the example though. Obj dump. I'm dumb. There is a lot more stuff when you have the D runtime in there. So if you strip out the D runtime, this is what a D program looks like with the full D runtime, without dash better C, what am I... It fills the whole terminal completely. That's the full, every symbol and every section. There's a lot of .text and row data sections still. This means you'd have to implement this at every single aspect of why this has things and where they're at into your like actual OS if you want to have anything that relies on the runtime. That's why high level languages are not great, in my opinion. Example.o, which is very null, but still, I feel this is valid. So you have D main, D3, all of, oh, but this is not as much. Text, data, BSS, text, row data, note, comment, data, row data, strl, and this is all way too complex for me to ever think I'm going to be able to implement such a complex runtime into it. And these are undefined, so. But that is crazy. So in a better C one, though, let's compile it with the better C DMD example. Without, let's do dash better C. And then we need to extern C. So let's go ahead and run extern C on it. I don't know if we can run extern C with the import. I don't think you can have anything that relies on the D runtime. So I don't think extern C and then put a colon afterwards. That will allow you to extern it as a C program. Let's go ahead and do that. DMD dash better C. Maybe the dash M32 also reduces it. GC. Let's see. K main, we have dash OF K main. Okay. But right, you can't really use anything that relies on the main runtime stuff. But let's remove the stuff that we have that depends on the runtime. For example, standard.writeLine is unusable because it relies on D runtime. So you cannot use standard.standard.io, but you can probably use the core stuff, which is the restrictions. See that? Now, let's go ahead and obj dump the example. A lot less symbols because the D runtime is not present. Now the D runtime is probably so complex because it has at least some level of optimization. Here's an abstract. Now if we did it with a dash M32, I'm sure it would actually be... There's still very interesting stuff going on. Like mangling, for example, I think is happening in some cases. These look really mangled, but actually no, they're not. They're not mangled. If they were mangled, it'd be like scrambled and shit. We wouldn't even be able to read these sections probably, but I don't know what these abstract are. I'm guessing it's like the undefined UND. .o. The .o has even less, but the final linkage has a lot more. So this one has only like text.main, BSS, text. A lot of what I could do to implement stuff with this is I could potentially use a hex editor to access it and then implement my own features into it. It's always possible. Now it's an ELF. You can see it's ELF 64-x86-64. So I do dash M32. Right here. Should give me What? Right, and then once a dash O. Example dot. Oh, right, but we need to run the linker with. See, the linker, you either pass the flag or you do dash F. Or no, you would do dash OF equals your file dot out, for example. See, I had this problem in a previous video where I had to make a 32-bit binary for some reason or something like that, and I was trying to cross compile for ARM, and we couldn't get the linker to work. But the reason that happens was because I could have bypassed the entire thing where I had to pass a linker flag by just doing it in the most jank way where I do the linking manually myself. I just didn't know how to use LD. Now I know how to use LD, which I should have known how to use LD because I'd used it before. I don't know why I didn't just think to go make an output file for example.o, for example, and kaboosh. But then we need to run dash C. So you do better C first, then you do dash C right there. And now it works. Now if I do that on example.o, object dump for example.o should be a lot less. Bro, it's like way less. It feels like, I feel like the 32-bit one has a lot less to work on. There's still text.main, group. A bunch of other stuff, but we have .text, we have .data. If we go back to the, we don't even have that. OBJ, oh, wait, why did it do a dash M32 there? That's actually not right. Let's try comparing that to the slash, the dot slash example. Dot slash tab boot .o, and we have data, and then there's a bunch of ABS sections. Example.d. So I guess that's yeah, that makes sense. The original file name is defined here in example.d, and then from down onwards, text, data, BSS. Here I have data, text, ABS, 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 which are just different things, instructions going on inside of the program before we get to the next section, which is at kmain, and then it goes to .text again at the end, which makes sense that it ends in .text as well. So the actual code execution happens either at this first one or the last one, because there's two .text. This is a row data section afterwards. We don't even have a row data section. So you do need row data, because if you're going to work with high-level language, apparently, probably all high-level languages have row data. That probably includes C. I would assume C also has that. Let's try the example output in here. Alright, objdump-h example.o, which is going to give you more information. That's going to give you your actual sections. The dash T was giving us our stuff. And these also give you alignments and information about where they align. So if you need to align them, you could do it with the linker. What I'm realizing, I think, is that you could probably program the whole thing 100% without using any ASM if you're like some kind of fucking giga genius. No, you'll probably have to write ASM for your functions, but the whole multi-boot header and all that, we could forget all that, I think. You could just be like, fuck ASM, bro. I'm just gonna do all of the multi-boot header in a high-level language, and then do everything, all my functions and shit will be ASM or something like that. Do some weird backwards stuff. I think that's possible. Now try the other one. .boot.o and do the -h on it. Just to get us an idea of what exact. Only 2 sections. But you'll notice data in this comes first. And that's because you need to get that done like as fast as you can, because obviously. Oh wow, it's even got alloc read only and stuff like that. But obviously you need to get this done early, because if it's not within like a certain byte range, or like what are they called, address range, something like that, then the bootloader won't be able to find it. So. And then this. But their alignments probably are supposed to be like the 4K ones. I don't know. Anyway, that's enough of fooling around with obj dump, which is pretty useful. Let's continue to the linker script section. Linker scripts are text files. You write your linker script as a series of commands. Each command is either keyword or possibly followed by keyword possibly followed by arguments, or an assignment to a symbol. But actually, I think we're gonna have to wrap it up here for today. So, because I'm pretty much, not only am I tired, but I have to go soon. So, I'd like to thank you all for watching. Well, if you all enjoyed today's episode, feel free to stay tuned for more, and I'll see you guys next time, and goodbye.